In this lesson, we're going to talk about rational exponents. That would be exponents that are fractions. In general, when the exponent is a fraction, we can evaluate that power by using square roots. So here's our general formula right here at the top of your page. So in general, if you are evaluating the nth root, we'll say, of a number, that's the same as evaluating that same number to the exponent 1 over n. So here we have a numeric example that might make this a little bit clearer. So in exponential form, we could write 2 to the exponent 1/5. In radical form, that would be written as so, the 5th root of 2. So those two things mean exactly the same. Underneath that, you have some commonly calculated roots and radicals. So that would be your square root, cube root, 4th root, and 5th root. So another way of writing the cube root of a number is to write that number to the exponent 1/3. Another way of writing the 4th root of a number is to evaluate that number to the exponent 1/4. And similarly, for the 5th root of a number, we can evaluate that number to the exponent 1 over 5. Now, let's go through a few examples here. It says evaluate if possible. So the cube root of -8, that would mean what number could I multiply by itself 3 times to get -8? And that number is -2. Because -2 times -2 times -2 is -8. Or in other words, -2 to the exponent 3 equals -8. The 5th root of 243 is 3, because 3 to the exponent 5 is equal to 243. Now the next one has a rational exponent. So 27 to the exponent 1/3. We can convert that to a radical using the list above. So it says the cube root of a number is the same as raising that number to the exponent 1/3. So 27 to the exponent 1/3 is the same as, let me fix that, is the same as finding the cube root of 27. And the cube root of 27 is 3, because 3 cubed is 27. When the base is a fraction, same thing. So 1 over 16 to the exponent 1/4 would be the same as finding the 4th root of 1 over 16, which is 1/2, because 1/2 to the exponent 4, not having a lot of luck with the pen today, I'm trying to write 1/2 to the exponent 4 equals 1 over 16. So let's try that again. 1/2 to the exponent 4 equals 1 over 16. There we go. Okay. Last one, the square root of -16. There's no number that I could multiply by itself that's going to give me -16 as an answer. So this one has no solution. You can't take the square root of a negative number. Now, what do we do if the fraction in the exponent does not have a 1 as the numerator? So notice these ones we had to evaluate in the previous example with rational exponents. In both cases, the numerator in the fraction was a 1. It's a little bit different if the value is not a 1. So suppose we have the radical 16 to the exponent 3/4. We can evaluate that 2 ways. We can, basically what we need to do is split the exponent apart remembering that 3/4 is the same as 1/4 times 3. So we're going to split this two different ways. One way would be to say 16 to the exponent 3/4 is the same as 16 to the 1/4 cubed. Another way to split that apart would be to say 16 to the exponent 3/4 is the same as 16 cubed to the 1/4. Both of those equal 16 to the exponent 3/4 because using our power of a power rule, when we multiply these exponents together in both cases, we get 3/4. So I could simplify this question either way. Now, the first way is rather easy to evaluate because 16 to the exponent 1/4 is the same as the 4th root of 16 cubed. The 4th root of 16 is 2, and 2 cubed is 8. So that one's rather easy to evaluate mentally. If I chose to answer the question this way, 16 to the exponent 3, if I use a calculator, is 4,096 to the exponent 1/4. So I would have to find the 4th root of 4,096, and it is 8, of course. We get the same answer, but that is much harder to do mentally. So when it says which one is easier, we would say the first one, because the 4th root of 16 is easier to evaluate than the 4th root of 4,096. So in general, it's better to keep the fraction inside, evaluate that first, okay, inside the bracket, and then put the numerator of the fraction outside. So there is a summary here of your two different methods, okay? So if you have a power, a to the exponent m over n, we could evaluate that in two ways. This first way would be raising a to the exponent m first, then taking the nth root, the second way, sorry, that should be 1 over n. The second way would be to take the root first and then raise to the exponent m. So we're saying this is the easier way. Now it's difficult to look at these formulas with the letters, I think. That's very confusing. So let's do a few examples here just to make sure you've got it. Okay, so we're saying if you're going to evaluate something like 32 to the exponent 3 over 5, what you're going to do first is split apart the exponent, and you're going to do that by putting the numerator of the fraction outside the bracket. So we'll make this 32 to the exponent 1/5 cubed. 32 to the exponent 1/5 is the same as the 5th root of 32. Still cubed. The 5th root of 32 is 2, and 2 cubed is 8. Okay, next one, 125 to the exponent 2/3. So same thing, we're going to keep the base, move the numerator of your fraction to the outside of the bracket. So we'll write 125 to the exponent 1/3 all squared. (125) to the 1/3 is the same as the cube root of 125, which is 5, and 5 squared is 25. And the last one is 8 to the exponent negative 5 over 3. If the exponent is negative, remember we write that as 1 over the same power with a positive exponent. And now we'll evaluate in the denominator. So we'll keep this 1 over. Now, that will be 8 to the 1/3 to the exponent 5. Remember that 8 to the exponent 1/3 is the same as the cube root of 8 raised to the exponent 5. The cube root of 8 is 2, and 2 to the exponent 5 is 32, so our final answer is 1 over 32. And that concludes this lesson.